Students, as we did in the previous video, our colloidal solutions, they get classified into three categories. Now the last category that is left behind, that is the classification based on the type of particles of dispersed phase, right? What type of particles we have in the dispersed phase? So according to that, we have three type of colloidal solution. One is multimolecular colloids, then macromolecular colloids, and associated colloids, right? Now in multimolecular colloids, multimolecular means so many molecules, right? So in this, the particles have usually diameter less than 1 nanometer, so they get aggregate. So we can say they consist of aggregates of atoms or molecules which generally have diameter less than 1 nanometer. अगर पार्टिकल्स का अपना साइज 1 नैनोमीटर से कम है तो सो मेनी पार्टिकल्स लाइक इन सल्फर सोल एसिड मॉलिक्यूल्स आर देयर, राइट? सो दैट मीन्स सल्फर atoms they aggregate to form the sulfur soul. Similarly in the gold soul, right? So in this, the small particles, small atoms, they or molecules, they aggregate to form the multimolecular colloids. For example, we have sulfur soul, and these colloidal solutions, they are usually they are lyophobic in nature, and their molecular mass is not very high. In this, the atoms are or molecules are held together by weak van der Waals forces. Now we have macromolecular colloids. In macromolecular colloids, they consist of large sized molecules. Okay, they are molecules, the size of the molecule is large enough. For example, we have starch soul, we have rubber soul, we have protein soul, we have nylon. All these are the examples of macromolecular colloids, and these colloids, they are usually lyophilic in nature, right? So in this case, we have high molecular mass, and the molecules are flexible, they can take any shape, right? Now the next one is associated colloids. Now in case of associated colloids, these are the substances which when dissolved in a medium, they behave as a normal electrolyte but at low concentration. But if you are going to raise the concentration, then they behave as a colloidal solution. तो अगर आप low concentration पे इनको लेते हो तो वो electrolyte की तरह behave करेंगे. But as you are going to increase the concentration, then they behave as a colloidal particles. So they consist of large number of ions which behave as colloidal size particle at higher concentration. Most common example is soap solution, your detergent solution. So these are the examples of associated colloids. Now I want to explain associated colloids, like we have an example of sodium stearate. This is an example of soap. It contains stearate ions and sodium ions. As you know, when we are going to explain the structure of soap molecule, it has a hydrophilic part, that is head, and hydrophobic part, that is tail, right? So when so many molecules, when so many ions, they aggregate, then these suppose here we have a dust particle, right? So this hydrophilic part, that is polar head part, it move away from the dust or grease particle, and hydrophobic part remains toward the dust particle or grease particle. So this is the formation of measles, right? So measle formation take place at a particular concentration, right? And it is a associated colloid. Now in this, we have most common terms that you may get 1 mark question from here, right? And that is Kraft temperature. The definition of this Kraft temperature is the formation of measles take place above a particular temperature, which is called Kraft temperature. And next one is CMC. The formation of measles takes place above a particular concentration, that is known as CMC, critical measleization concentration, right? Critical measleization concentration, right? So that is the last type of classification, that is the based on the particles of dispersed phase. Now we have next topic, how we can prepare the colloids, because our colloids, they are classified into two categories, lyophilic and lyophobic colloids. So lyophilic colloids, because suppose this is the dispersed phase and this is the dispersed medium, right? If this dispersed phase and dispersed medium, they both have interaction with each other, they both are loving for each other, then if you simply shake them, then you can prepare the lyophilic colloid. But it is not easy to form the lyophobic colloids, because in case of lyophobic colloids, there is no interaction between dispersed phase and dispersed medium, right? So in this case we need some special methods, and methods are classified into two main categories, that is dispersion or disintegration method and condensation or aggregation method. As it is clear from the name, disintegration method means you have to separate something, you have to dissociate something, and aggregation means you have to arrange something, you have some of the things they come close to each other. Disintegration method is further classified into electrodisintegration, that is Braddock's arc method, and next is peptidation method, right? And in this case we have aggregation method is done by chemical method, that is double decomposition, reduction, oxidation and hydrolysis, right? So you have to note down this flow chart, right? After that we are going to explain first method, that is dispersion method. dispersion method में सबसे पहले explain करेंगे electro disintegration, that is Braddock's arc method. In Braddock's arc method, it is used to prepare colloids of metals such as gold, silver, right, platinum. So these salts are prepared by this method. Now in this we have one term, that is purple of gaseous, that is the colloidal solution of gold. For the colloidal solution of gold we can use this term, purple of gaseous, right? So what type of method, how we can form this type of colloidal solution? You can see the arrangement. In this we have a tank in which we will take water, right? The water will act as dispersed medium, clear? And we have another container in which we have ice. I will explain you the role of ice in this, right? And we have here two rods. Suppose you want to form the colloidal solution of silver, then you will take the rods of silver. If you want to form the colloidal solution of gold, you will take gold. And if you want to form the colloidal solution of platinum, then you will take the rods of platinum, right? And one rod is connected through anode and another one through cathode, right? Now in this case, as it is means it is connected to a high voltage, right? So as you connect it through high voltage, right, a arc get formed over here, right? So the particles, these particles, gold particles, they separated out and they get vaporized, right? So they get vaporized. So in order to condense those vapors we have ice, राइट? सो पार्टिकल्स जो हैं गोल्ड के वो यहीं पे रहेंगे, ठीक है? अब फर्स्ट प्रॉब्लम तो सॉल्व होगी कि पेपर्स जो हैं वो वेपराइज नहीं हो रहे हैं, ठीक है? क्योंकि इतना ज़्यादा हमारे पास यहाँ पे जो हमारी मतलब गोल्ड के पार्टिकल्स हैं वो एकदम से वेपर स्टेट में जाएंगे, हाई वोल्टेज हमने दिया है तो एकदम वेपर स्टेट में जाएंगे, तो वो तो हमारे एकदम से कंडेंस हो गए, मतलब मीन्स वाटर में आ गए. पर अगली प्रॉब्लम क्या है कि हो सकता है ये पार्टिकल्स दोबारा से एग्रीगेट कर जाएं, ठीक है, और फिर से रॉड बना दें, राइट? तो उस प्रॉब्लम को सॉल्व करने के लिए वी विल ऐड इन दिस KOH, right? So KOH will stabilize the colloidal solution. Now how it will stabilize the colloidal solution? Suppose you have gold particles in the water, right? Now these gold particles, they attain negative charge around them. Now all the gold particles if attain negative charge, that is the hydroxyl part, OH part, right? So they will start repelling each other. They will not come close to each other. If they will not come close to each other, that means our colloidal solution is stable now. Otherwise, if these gold particles they come close to each other, they will again form gold rod, right? So that means KOH will act as a stabilizer in this, right? And next we will discuss in the next video.